Welcome to your custom deep dive. And you sent us a really fascinating stack of materials today.
Yeah, a really dense stack, honestly.
Right. We've got developer notes dated April 30, 2026. We have quick start guides, a bunch of UI screenshots, a vlog script, and, an MIT license file.
All coming from C Code Studio.
Exactly. And, reading through all this, it all centers around a problem that you probably know intimately if you spend, any time in modern 3D pipelines, which is dealing with just melted, chaotic geometry.
Right, the dreaded unreadable mesh.
Because usually when we think about creating a 3D model, there's this expectation of pristine hierarchical organization, right?
Absolutely. You expect clean data.
Yeah, you have your subtools, your vertex groups, your clean edge flow. Basically, everything is a distinct labeled part that you can just isolate and manipulate.
And that is the ideal state of any 3D workspace. We rely on that structure to rig, to animate, or even just to apply complex material setups.
Oh, for sure.
But the reality of current production environments is, it's shifting rapidly away from that ideal.
Radically shifting, because the second you step into the world of, say, high-res photogrammetry
or AI generation.
Right. You pull down a raw mesh generated by a text-to-3D AI model, and that organized hierarchy is just completely gone.
It doesn't exist.
Let's say you generate a sci-fi mercenary character, and you want to take the armor off to adjust the clothing underneath.
Which is a standard request.
Totally standard. But instead of separate objects, the AI gives you...
Well, it's like someone took a highly detailed model and just threw it in a microwave.
That's a great way to put it.
Right. It just fused the armor, the skin, the weapons, the gear. It's all one single monolithic block of vertices.
And trying to manually untangle that single chunk of raw geometry, it stops production dead in its tracks.
Oh, it's a nightmare.
Selecting faces loop by loop on a really dense triangulated AI mesh. It's the definition of a workflow bottleneck for technical artists today. Which is exactly our mission today. We are taking that specific problem, that fused, unreadable block of digital clay, and breaking down how to transform it back into organized, usable parts.
And the kicker here, what makes this really special, is we are looking at a workflow that does this entirely inside Blender.
Yes.
Without ever having to round trip to another piece of software.
Which is huge. And the tool you had us look into for this is a Blender add-on called Mesh Face Groups.
Right. And staying inside the native environment is a massive advantage here. Historically, if you had a dense, unstructured mesh, the standard operating procedure was you export your OBJ.
Oh, I've done this so many times.
Right. You fire up something like ZBrush or Mesh Mixer, run some polygrouping algorithm, export it again, and then drag it all the way back into Blender.
Hoping nothing broke along the way.
Exactly. Because every time you leave your primary software, you introduce friction. You get potential scale issues, transform errors. It's just risky.
Okay, let's unpack this. If we have this giant chaotic block of thousands of triangles making up our mercenary character, how is this add-on actually making sense of it natively?
It's all about the angles.
Is this basically like drawing borders on a topographical map where the software, drops a borderline every time the slope gets too steep?
Yes. The topographical map analogy captures the core logic beautifully. But the add-on is calculating those slopes on the fly using something called angle-based grouping.
Okay.
So it evaluates the dot product between the normals of two connected faces.
Meaning the direction they're pointing.
Right. If the normals are pointing in roughly the same direction, the script just groups them together.
Makes sense.
But when the surface hits a sharp bend, say, the edge of an armor plate transitioning into the fabric of the character's sleeve, the angle between those normals exceeds a certain threshold.
And boom, new group.
Exactly. The tool initiates a completely new face group right at that crease.
So it's literally just mathematically mapping the sharp crevices and hard edges to find the natural breaking points.
Yes.
And the way you interact with this, looking at the quick start guides, it seems designed to be incredibly fast.
It is.
You just ensure you are in object mode, right? Not edit mode, which the notes say is a really crucial distinction for performance.
Very crucial. Edit mode will bog down the calculation on high poly meshes.
Good to know. So you're in object mode, and you open the Face Groups tab in the sidebar using the N key. But the feature that really stood out to me in the UI screenshots is the live preview.
Oh, the live preview fundamentally changes the iteration speed.
Because you can actually see it working.
Right. In older Boolean or grouping workflows, you would type in an angle value, hit a process button, and wait.
And wait and wait.
And wait for the calculation to finish. And then if the mesh shattered into 1,000 useless pieces because your guess was wrong, you had to undo and guess a new number.
Which is incredibly frustrating.
But here, the add-on hooks directly into Blender's viewport shading. It recolors the mesh in real time.
I love that. So as you drag the angle threshold slider, the colors on your model are just actively shifting and merging.
You get instant feedback.
You can actually see the borders wrapping around the geometry before you even commit to anything.
And speaking of that slider, the developer notes are very explicit about where to begin.
Yes, the golden rule.
Exactly. They establish a golden rule.
Right.
Always set your baseline angle threshold at exactly 10 degrees.
Why 10 degrees specifically?
10 degrees provides the optimal mathematical baseline for separating deliberate structural changes from, like, subtle surface curvature.
Okay, so it ignores the small bumps.
Right. And from there, you just tune it based on visual feedback.
Yeah.
If you lower the threshold towards 0, you're demanding that faces be nearly perfectly flat, coplanar, to stay grouped.
Which would make it super strict.
Incredibly strict. It generates highly granular zones. But raising the threshold above 10 makes the algorithm more forgiving.
Letting it wrap around stuff.
Exactly. It allows smoother transitions, like a gently curved helmet, to merge into a single unified group.
Which makes total sense for a hard surface model, something with obvious machined angles.
Sure.
But, I mean, running pure angle math on a raw 3D scan or an unrefined AI mesh, that feels like a recipe for disaster.
Oh, it absolutely can be.
Because it's like trying to draw borders on a crumpled up piece of paper based only on the folds. You just end up with 1,000 useless microscopic zones, right? Every little anomaly or scan artifact is technically a steep angle change.
That crumpled paper effect is exactly the inherent flaw of relying solely on angle calculations.
So it just shatters visually.
Right. A raw, noisy mesh will generate hundreds of tiny groups that clutter the viewport and basically ruin the segmentation.
But I'm guessing the developers knew that.
They clearly anticipated this, which is why the grouping calculation is really only the first step.
Okay.
The add-on includes a secondary processing layer that's specifically designed to tame that noise before you extract anything.
Yeah, looking at the workflow guides, there are two distinct cleanup modules here. You have small island cleanup and floating island cleanup.
Right.
And let me logically break down how the software might handle this, because I feel like the distinction matters. For floating islands, let's say I scan our sci-fi character. The floating dust particles or like scanner glitches aren't attached to the mesh at all.
Right, they're just hanging in space.
Right, so I assume the tool just isolates anything that shares 0 vertices with the main body.
That is the exact discriminator it uses. If there is no vertex sharing, the algorithm flags it as an isolated floating shell.
Just entirely disconnected debris.
Yes.
So with those, you can just tell the add-on to ignore them during the grouping process, or, and this sounds highly satisfying, you can use the Delete Floating Islands button to permanently purge that disconnected garbage from the scene.
It is very satisfying to click.
I bet. But, okay, small islands have to be more complex.
They are.
What is the actual difference between a small island and a floating island? Aren't they both just junk geometry we want to get rid of? We are talking about attached noise here, like a rogue, bumpy artifact fused directly onto the character's shoulder armor. You can't just delete that.
Well, what's fascinating here is how it handles that attached noise.
Yeah.
Because you're right, deleting an attached island would rip a physical hole right through the topology of your mesh.
Oh, that would be bad.
You'd ruin the model.
Yeah.
So instead, the small island cleanup tool uses a healing mechanism.
Healing, like smoothing it out.
More like merging it logically.
Mm-hmm.
It evaluates groups based on user-defined parameters for small island area and min-island faces.
Okay.
So if a group falls below those thresholds,
Mm-hmm.
let's say it's just a tiny cluster of 10 noisy faces sitting right on the shoulder, the tool strips away its unique group ID.
And does what with it?
It forces it to inherit the properties of the largest adjacent face group.
Oh, wow.
Yeah, it effectively absorbs the noise into the surrounding surface logic.
So it heals the visual noise without destroying the underlying geometry. That's brilliant.
It is.
Now, speaking of avoiding destruction, there is a very specific troubleshooting detail hidden in the quick start common errors that we really need to highlight for you.
Yes, the trellis warning.
Right. In the cleanup section of the UI, there is a toggle called Auto Trellis Mesh Repair.
Right.
And the guides explicitly warn that checking this box will cause the entire process to fail if you don't know what you are doing.
And a lot of users don't. Because trellis is a completely separate, external, AI-driven back-end repair pipeline.
It's not built into the add-on natively.
No, it's not. When you click that toggle in the add-on, Blender actively looks for that specific trellis code library on your local environment to pass the mesh data to.
And if it's not there?
If you haven't manually installed the trellis framework and set up the necessary paths, the script hits a dead end, throws an exception, and the whole operation just halts.
So it's essentially just a hook for a separate piece of software. If you don't have the plumbing installed, do not flip the switch.
Exactly. It's a very common pitfall for users who just want to click every repair button they see. Keep it disabled unless your pipeline specifically requires it and you have it installed.
Good advice. Okay, so here's where it gets really interesting.
Let's hear it.
Up until this point, we have just been manipulating viewport colors, right? We dialed in our 10-degree baseline, we absorbed the attached crumpled noise, purged the floating debris, and sidestepped the trellis error.
You have a beautifully color-coded character.
Right, but it is still just one fused block of geometry with a fancy shader on it. It's time to talk about extraction.
This is the crucial pivot. Moving from a visual preview to generating tangible, actionable assets.
Right.
Because the entire purpose of that whole setup phase is just to feed clean data into the extraction operator.
And the primary engine for this is the separate groups into objects toggle. When you enable this and hit generate, the script just automates a massive amount of manual labor.
It really does.
Like, it duplicates your original source mesh for every single colored group you mapped out.
Right.
Then it iterates through each duplicate and surgically deletes every face that doesn't belong to that specific group's color ID.
And the non-destructive nature of that operation is vital. I mean, your original imported mesh remains completely intact in the outliner.
Which is so safe. And the add-on just utilizes the auto-hide source mesh feature to instantly turn off the visibility of the original block once the calculation is done.
So you don't even see the clutter.
Exactly. You are left staring at real individual Blender objects neatly separated. However, looking at the extraction settings, there is a toggle called Make Parts Watertight. This automatically runs a fill operation on any open boundary edges created during the separation. And I actually have to push back on leaving this on by default.
Go ahead. Why is that?
Well, if I am taking apart our sci-fi mercenary specifically to, say, re-rig the model for a game engine, meaning I want the armor plates to slide naturally over the undersuit, wouldn't automatically filling all those separation rolls completely ruin the fit?
Yes.
Right? Because capping off the inside of a shoulder pad would create this flat polygon plane that just intersects wildly with the character's arm beneath it. When would you actually want this on?
You're right. It would create an immediate collision nightmare during animation. But the concept of a watertight Boolean, creating a fully enclosed volume with no manifold errors, is designed primarily for additive manufacturing.
Oh, for 3D printing.
Exactly. If you are sending that separated armor piece to a 3D printer, the slicing software requires a closed volume to calculate the infill.
Ah, okay. So if you are printing, you need it solid.
Yes.
But if you're animating, you absolutely must disable Make Parts Watertight so the armor remains an open shell that can actually slide around.
Precisely. And, if you do want those extracted parts to remain open shells, but you need them to have a bit of structural heft.
So they aren't just infinitely thin polygon paper.
Right. The tool offers a shell thickness setting.
Oh, nice.
It actually bypasses complex extrusion math by piggybacking right on Blender's native solidify modifier.
That's smart.
So you can just dial it up to give your extracted armor plates a specific uniform thickness extending outward from the cut.
Okay, so we hit generate. We now have dozens of perfectly separated, potentially thickened, color-coded parts.
Beautiful.
But because they were extracted in place, they are all sitting in the exact same coordinates in the 3D viewport.
Yes, they are.
They are perfectly overlapping, forming the exact shape of the original AI mesh. How are we supposed to verify the integrity of the cuts without, manually grabbing the move tool 50 times?
Which would take forever. This brings us to a feature that solves a major quality assurance headache. The exploded view.
I saw this in the screenshots.
Because when you shatter a model into dozens of components, you have to inspect the boundary lines. You need to know, did the forearm separate cleanly from the elbow? Are there any stray vertices left over floating around?
And you just can't see the internal structure if the parts are resting perfectly flush against each other.
Right. So you go to the explosion section in the sidebar, you check explode separated parts, and you use the explode distance slider.
And as you push it, the individual pieces physically fly apart from each other in real time.
It's a great visual.
But there are two distinct mechanical modes controlling how they spread, right?
Yeah.
Dictated by the explode spread drop-down.
Yes. If we connect this to the bigger picture of inspecting data, these two modes serve different purposes. The first mode is center out.
What does that do?
The script calculates the bounding box and the central mass of the entire collection.
Okay.
And it applies a translation vector, pushing every generated part directly outward from that central origin. It behaves exactly like a natural radial explosion.
Okay, so it looks very cinematic,
It does.
but maybe not the most organized setup for technical inspection. Which brings us to the second option, called even XYZ spread. And looking at the UI screenshots, this forces a completely different layout. It overrides those radial vectors and pushes the parts into this highly regimented grid-like alignment.
Which is incredibly useful.
I love this visual. It looks exactly like when you open an IKEA manual and they show you all the screws, the brackets, and those little wooden dowels laid out perfectly flat before you start assembling the furniture.
That's a perfect comparison.
Yeah.
It is an incredibly clinical way to view your data.
Yeah.
For a technical artist or, say, a developer debugging an AI generation pipeline, that even XYZ spread allows you to take clean, orthographic presentation screenshots of every separated asset.
With no overlapping geometry.
Zero occlusion. You can see exactly what the model produced.
And you can even restrict the axis, too. There are X, Y, and Z toggle buttons right next to the slider.
Yes, very handy.
So if you only want the parts to slide apart horizontally but stay locked vertically, you just toggle off the Z-axis. It flattens the entire explosion onto a single plane.
Exactly. Though, reading through the guides, it's important to note that this explosion utility only functions on the final extracted objects.
Oh, really?
Yeah, you cannot explode the live preview colors before you hit generate.
Ah, okay. Why is that?
Well, the underlying architecture requires separate object data blocks to actually apply those translation vectors. The live preview is merely a dynamic visual shader applied to a single mesh surface.
Right, it's just paint on the fuse block until you hit extract.
Exactly.
Now, despite how powerful this workflow is for taming chaotic meshes, there is a fundamental limitation explicitly called out in the vlog script source we reviewed.
The big one.
Yeah, and anyone using this add-on needs to manage their expectations, specifically regarding smooth organic geometry.
Definitely.
Because this tool relies on geometric math, specifically, comparing the angle of face normals. It operates with zero semantic understanding of the model.
And that is a critical distinction between algorithmic processing and artificial intelligence.
All right.
The add-on is calculating localized dot products. It has absolutely no concept of the global structure.
Right. If I feed this tool, our mercenary character, the software recognizes a sharp 90-degree crease in the geometry where the armor meets the arm. But it doesn't know what an arm is.
Nope.
It doesn't know what armor is. It is entirely blind to the context of the shape.
And this becomes the primary friction point when dealing with highly stylized or really smooth character models.
Like organic shapes.
Yeah. If you have a creature designed with sweeping continuous curves and no sharp anatomical creases, angle-based grouping will really struggle to find a definitive mathematical threshold to separate the shoulder from the torso.
Because the slope never gets steep enough.
Exactly. The normal transitions are just too gradual to trigger a new face group.
So even after dialing in the perfect slider settings and cleaning up the noise, if you are working with smooth organics, you're likely still going to jump into edit mode to make some manual polygrouping adjustments before extraction.
Almost certainly.
It's an incredible first-pass tool, but it doesn't eliminate the need for an artist's eye on soft surfaces.
It excels in domains with defined structural transitions. So hard surface modeling, architectural photogrammetry, mechanical AI generations. For organics, it does the heavy lifting, but manual refinement remains part of the pipeline.
Well, to wrap this all up for you, mesh face groups, specifically version 1.3.0, which you install via the provided distance zip file, it really solves one of the most frustrating bottlenecks in modern 3D pipelines.
It's a game changer for raw meshes.
It really is. It takes the nightmare of uneditable monolithic messes and provides a streamlined, non-destructive extraction workflow natively inside Blender.
No exporting required.
Right. You load your melted block of geometry, you establish your 10-degree baseline, merge the crumpled noise, extract watertight or solidified open shells, and then you just explode them into a clinical grid for inspection.
It fundamentally bridges the gap between raw, unstructured generation and usable modular assets.
So what does this all mean?
Well, this raises an important question about the trajectory of our production tools.
Oh.
Yeah. We spent this entire deep dive analyzing how to leverage geometric math and normal angles to tame the chaotic outputs of AI generation.
Right.
But building directly on that limitation, you brought up the fact that the add-on doesn't semantically understand what an elbow or an armor plate is.
Yeah.
If we are already utilizing AI to generate these complex fused topologies, how long until true semantic AI understanding is integrated into the cleanup and segmentation tools themselves?
Oh, wow. So instead of calculating angles, it actually parses the object.
Exactly. Imagine a near-future workflow where you bypass the angle threshold slider entirely.
Okay.
You select your raw messy scan and you simply type a prompt into Blender, separate the mercenary's armor from the body.
That would be insane.
And the software understands the semantic concept of armor. It identifies those specific regions, regardless of how smooth topological transition is,
Yeah.
and executes the extraction.
Because it knows what it's looking at.
Right. As our purely geometric math-based tools reach their operational peak, the next massive leap forward isn't going to be a better algorithm for calculating face normals.
No.
It is going to be software that actually comprehends the context of the geometry it is processing.
We are moving from pure geometry to actual comprehension. That is a wild paradigm shift to think about.
It's coming faster than we think.
Well, until that day arrives, we still have to wrangle those normals ourselves. Thank you for joining us on this deep dive. If you are currently staring at a massive fused block of 3D geometry, go give up the add-on, set that baseline to 10 degrees, and see what can break apart. And remember, sometimes that jagged, unreadable blob isn't permanently broken. It is just waiting for the right tool to help you see the pieces.